starting with the linear pair postulate, or LP post if it comes up in a proof. Were linear pairs supplementary or congruent? Raise the hands. Who thinks supplementary? 3. Who thinks congruent? Shockingly enough, there are way more than 4 people in this room. We are going to try this again. Who thinks supplementary? Raise your hands high. Okay. Who thinks congruent? Okay. Supplementary wins, and supplementary is accurate. What does supplementary actually mean? Does it mean they're the same? Does it mean they add up to something? Yeah. They add up to 180. Thank you, Gib. So, if I see a picture like this, then I should know that the measure of angle 1 plus the measure of angle 2 is always going to be equal to 180. That was what we got yesterday. We also got vertical angles. Vertical angles, are they supplementary or congruent? They are congruent. Congruent meaning they are the same. So for vertical angle theorem, the measure of angle 1 is equal to the measure of angle... Which one's vertical to 1? 2. Or you could have that the measure of angle 3 is equal to the measure of angle 4. This is what we talked about yesterday. These are angle pairs that share a vertex. Today we're getting into section 3.2, which I believe starts on page 5 of your notes. If you don't have it open, open it. That's where we're going. Today we're adding angle pairs. But these angle pairs all work with what's known as a transversal. A transversal is a line that intersects 2 or more coplanar lines at different points. That's its technical definition. Essentially, a transversal is a line that goes through 2 others. It's really all it is. So, if I've got a line here, let's call this line F, and I've got this other line here, let's call it line G. A line that goes through both of them is a transversal, which we're going to call T. That's all a transversal is. Is a line that goes through 2 others. Now, when we talk about transversals going through 2 other lines, a lot of angles all of a sudden show up in this picture. How many angles are in this picture? 4. How many? There are 8 angles in this picture. 1 here, 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 and 1 here. 8 angles are made. Now, some of these angles in this picture fit the angle pairings that we talked about yesterday, such as these 2 right here on the very top would be a linear pair, or opposite of how they cross would be vertical angles. But our new angle pairs that we're going to be talking about are the types of angle pairs that do not share a vertex. So one of the angles is going to be of these top 4, and one of them is going to be of these bottom 4. There's going to be a lot of different types of angle pairs that we can work with. Today we're talking about corresponding angles. which you will see me shorten all the time as CA. Corresponding angles, in its technical definition, are two angles whose positions are on the same side of the transversal, and their corresponding position compared to the lines being cut is also the same. Definitely clarified exactly what it means, right? I'm being sarcastic, it definitely doesn't. Corresponding angles. If I look at this picture right here, it's got a set of them. They call it angle 2 and angle 6. Here's my transversal. Do you notice that they are both, in this case, to the right of the transversal? That's the first thing. They are both on that same side of the transversal. The other thing that is true about them is that when it comes to these angle pairs, the stuff between the two lines cut is called the interior, and the stuff outside is called the exterior. And so when it comes to corresponding angles, they're on the same side of the transversal. One of the angles is going to be interior, between the two lines. One of them is going to be exterior, outside of the two lines. But they cannot share a vertex. Two lines cut by a transversal. Let's say I'm talking about this angle. If I want a corresponding angle, I have to stay on the same side of the transversal. They both be on, in this case, on the left side. On the left side, I've got 1, 2, 3, 4 angles. That one's already marked as 1. The corresponding angle, since this one's on the outside of the two lines cut, it's in the exterior, would have to be one of these two inside, but it cannot share a vertex. Is it the top one inside or the bottom one inside? If it cannot share the vertex, if it cannot share that point, yes, it'd be the bottom one. So that angle and that angle would be another set of corresponding. Let's go back to your yellow sheet. Go back to your postulate sheet. Corresponding angles. One and 5 are the ones that we just pointed out. 2 would also correspond with 6. 3 would correspond with 7, and 4 would correspond with 8. Now keep in mind that the transversal does not always need to go up and down. It can go sideways. I've spun it. The corresponding angles are still 1 and 5, 2 and 6, 3 and 7, 4 and 8. Still the same pairs you told me last time. So, today we're going to be identifying corresponding angles as well as the angle pairs that we dealt with before. Like this one here. What kind of angle pair was this one? It's a linear pair. Or ones like this one, which are what type? Vertical angles. Okay. So, we're identifying the following as linear pair vertical angles adjacent or corresponding, if any of them. Okay, so I'm looking at this problem here. My angles are that one and that one. Do they share a vertex? Do they share the point in the angle? Mm-hmm. No. One vertex is here, one vertex is here. Which means it cannot be a linear pair, it cannot be adjacent, it cannot be vertical. Are they corresponding? Are they on the same side of the transversal? Yep. Is one interior, one exterior? Those are the requirements. So yes, this is corresponding. Problem 2 has this angle and this angle. Do they share a vertex? If so, it's an old style. It's like yesterday's stuff. They share a vertex right here. Is this adjacent, linear pair, or vertical? Linear pair. They're making that line. I'm going to be going to my name cards because I'm hearing a lot from the same people. Question 3's got that angle and that angle. First off, Jonathan, do those two angles share a vertex? No. Nope. So that means they'd have to be a new style one. Can't call them people who aren't here. Joy, are they corresponding? Yes, they're on the same side of the transversal. One interior, one exterior. Question 4. This angle and this angle. Kenna, do they share a vertex?
Yeah.
Yes, which means they're yesterday's style of angle pairs. Tristan, would you say these are adjacent, a linear pair, or vertical? Just plain old adjacent. Okay, question 5's got this angle and this angle. Aiden, do they share a vertex?
Yeah.
Yes, they do, which means we're thinking yesterday's type. Amari? What kind of angle pair are you thinking on that one? Linear pair, vertical, or adjacent?
Vertical.
You got it. Because they are forming the X. Last one uses this angle and this angle. Ella, do they share a vertex? So the vertex is the pointy part of the angle. So if I do this, that's this one's vertex.
Yeah.
Then yes, they share a vertex. Gabe, what kind of angle pair are you thinking for 6?
Vertical angle.
That's vertical angles again because they're forming the X. Now, much like yesterday, knowing what kind of angle pair it is will tell you what is true about it. If you have corresponding angles, then they are congruent, according to what's known as the corresponding angles postulate. Now, we went through this already. They are congruent, meaning they are equal. So measure of angle 1 is equal to measure of angle, which one corresponded with 1 again? 5. Because it needs to be, 1 is external, and on the left side. I need internal on the left side, but not right next to it. Angle 5. Or, angle 2 corresponded with which one? 6. So measure angle 2 equals measure angle 6. Or, measure angle 3 is equal to 7. 3 goes with 7. Or, last but not least, measure angle 4 goes with 8. So, we're identifying angle pairs, and we're solving again. Label the transversal T, name the relationship between the given angles, and solve. So the transversal is the line that goes through 2 other lines. Specifically, the transversal should go from one angle to the other angle, because sometimes there's going to be a lot of lines going through 2 others. In this case, this line's going through 2 others, and it's going from one angle to the other, so that's our transversal. I'm going to label that T. Okay, I've got this angle and this angle. Jackson, what kind of angle pair do you think these 2 are? start with this. Do they share a vertex? Do they share the pointy part of the angle? No, because one's here and one's here. That means it would have to be the new style. So far we've got corresponding. Corresponding requires they're on the same side of the transversal. Are they? Yeah. It also requires one to be inside the two lines and one outside. Is that true here? So they are corresponding. And if they are corresponding, that means they are equal. So, new seating chart, and I have to look around for you guys on where you're sitting now. Kata, what would the equation look like then? Corresponding means they're equal. You got it. For the sake of time, do you trust my solving skills today? No? I guess you could solve it on your own if you really want. In the meantime, x is 11. Okay. Question 2, I've got this angle, and I've got this angle. Corey, what kind of angle pair are we thinking on this one? Looking back at the right spot. I'm liking it. Yes, that's exactly right. They are adjacent. Do you notice that adjacent isn't on your yellow sheet? Do you think there's a reason for that? Didn't we have adjacent show up on our orange one from last chapter? Wasn't called adjacent angles. It's the angle addition postulate, and it says take the little one, add the little one, make it equal to the big one. 5x plus 3 is one of the little ones. 2x plus 10 is the other little one. What is the big one in this picture? 90. Got our right angle hanging out there. Now, while some of you have indicated that you do not trust my solving skills, and for valid reasons, I will tell you again, x is still 11. Sake of time, we're going to skip question 3. Move on to question 4. Ooh. Back up a little bit. Go back to question 2 for a second. We missed a part of the instructions. Did I label a transversal?
No.
No. But did I talk about transversals yesterday? No. Because the old angle pairs don't have transversals. It's only the new ones that have transversals. It's only the new ones that you have to worry about a line going through two others. Okay, back to where I was on 4. That angle and that angle. Lexi, any thoughts on what type of angle pair that could be? Okay, if we're not sure, let's go through the questions that we need to go. First off, Lexi, do they share a vertex? Do they share the pointy part of the angle? Is it the same? for this one and this one. This one's pointy part's right here. This one's pointy part's right here. Not the same spot. If they don't share that, that means they'd have to be the new style angle pair. So the new style angle pair we've got is corresponding. Corresponding says they have to be on the same side of the transversal. Which one's the transversal? One going up and down, the top one or the bottom of it? Up and down. So that's our transversal. Are they on the same side of it? Yeah. Yes. Is one inside and one outside? One in? Yes. That's corresponding. So that fits. Louis, if they're corresponding, what did we say we know about them? Are they supplementary or are they congruent? Nope, you're right the first time. Congruent, in other words, they are equal. -3 plus 23x equals 21x plus 9. X will not be 11 this time, it'll be 6. Okay, we're going to take a look at 5 and then we are going to be done with notes today. I want to take a look at 5 because 5 is a more complicated picture. Do you notice that there are a lot of lines that cross through two others? Yeah. There's extra lines here. I'm working with this angle, and I'm working with this angle. This line has nothing whatsoever on it. It is extra information. Charlie, what kind of angle pair are we thinking for these two? They are corresponding because they're on the same side of the transversal, which is that. It's a line going through two others. One's interior, one's exterior. And if they are corresponding, they are equal. So, if you did not already add it to your yellow sheet, I highly recommend you add your corresponding angles postulate to this sheet. Because as we get more and more angle pairs, having them all in one place is going to be helpful as we are solving.